this. So there's a wonderful question from a participant. Um, are agent-based models equivalent to individual-based models, or are they a subpart of individual-based models? Or are individual-based models a subpart of ABMs? This is a topic I've actually taken on with the okay, I've got to avoid more diving because some TAs are still arriving and so on. So I've taken on this topic in some of my writing, but I do so with a certain degree of hesitancy, thinking back to Richard Feynman's injunction that actually from his father passed on to him, and passed on subsequently, and surely you're joking, Mr. Feynman, that we shouldn't get ourselves too vested in fights over labels. And I'm partial to that view because his father said 95%, something like, no, maybe it was 80% of all conflicts in the world are because people are fighting over labels. And Richard Feynman said later he realized that his father, well, his father was a very wise man, and the comment was generally a wise one. His father was actually quite off. It's Richard Feynman said it's more like 98% or something of conflicts in the world are about labels. And so I'm cautious about wading into, what is the proper definition, the fulsome definition, but I am partial to useful taxonomies. So I'll give it a shot. And my thoughts on this haven't changed a lot over the 10 or 15 years since I first wrote about it. So to answer this effectively, I'll just say that there are a set of cognate kind of methods that I think are possibly close enough to ABMs to merit discussion in these events, and they have tremendous sort of overlap in spirit and needs in some regards. And I put up here agent-based models, and I'll say individual-based models, sharpening that word, but more generally individual-based models when it comes to things like microsimulation. But I have to be careful here because discrete event simulation is actually an individual-based method. And discrete event simulation distinguishes particular types of what might informally be called agents. And in fact, in any logic, they are called agents, but in the literature, they tend to be called entities. And they're particular actors that are somewhat passive, despite that name, and they flow through workflows that are capacity, where progress along them depends on availability of resources, where those resources are typically a fixed capacity or limited capacity. So here in discrete event modeling, the sort of things on which the workflows at the center of discrete event modeling are focused, things like patients in a healthcare facility, or things like doses of vaccine and vaccine creation, or individuals whose application for social insurance, say housing assistance or income assistance, is being evaluated in some process. Those individuals are distinguished. So it is an individual-based modeling tradition. And I would say that, however, I view it as rather distinct because discrete event simulation, as we'll see, has a really central focus on process through work of entities or agents through workflows, focused on the impacts of resource availability, placement in some cases in space, on the flow of these entities through the system. It's a very asymmetric tradition where you have like entities that are being operated upon by resources, and you may have, and you commonly will have resources individuated, like doctors, nurses, gurneys, so hospital beds, wheelchairs, ultrasound machines, portable ultrasound machines, whatever. And these are individuated. They're individual. You distinguish individuals. But it's very asymmetric. And you're kind of operating upon these entities that are flowing through the system, and their ability to make progress is contingent on having certain resources. Again, often doctors, nurses, hospital bed, procedure room, x-ray machine, whatever. So I don't really think of that as kind of a very, very comparable. When I say comparable, I don't mean it's, I don't think it's really, I think it's a quite different tradition within dynamic modeling. I think they're close cousins in the broader landscape of dynamic modeling. I mean, well, in overall methods used in health sciences, they're very close cousins. They're both dynamic modeling methods, but it's not really the same tradition as agent-based modeling or individual-based modeling as that might include ABM. Where I've used this IBM in the past. So first of all, why isn't agent-based modeling called IBM, called individual-based modeling? That's a good question. And my distinct understanding from those who have written about it is that much early formative work on ABM went on at Los Alamos National Labs. And in fact, you can go back longer than that and look at the work of John von Neumann, who was doing work with ABMs of sorts, or individual-based models of sorts with cellular automata back in the 40s, together with Stanislav Ulam. But Los Alamos National Labs was kind of a hotbed for this, and out of that came Swarm, an early agent-based modeling framework, et cetera. Now, Los Alamos had a countercultural kind of bent, and the agent-based modelers there really disliked the idea that their tradition would be called IBM, because IBM was a dominant company at the time. It was associated with a very staid, what they viewed as very rigid, bureaucratic, old school, pinstripe suit business culture. And so my understanding from this historical account is they chose not to name it IBM, individual-based model, because that was associated with the company, or, they didn't want to use the same one and remind people of the company. They thought it was much better than the company, much more insightful, much more powerful, what have you. And so they named it agent-based model. Now, in today's context, there is a very important question, like, should we retain that? And I've been known to argue that it's time for us to avoid focusing on the word agent and agent-based model, and I prefer individual-based models for a couple of reasons. One is it can be taken as including microsimulation as a tradition. Microsim is much closer to the agent-based model, not only in that it's an individual-based tradition, but it's also a tradition which has a broader frame than discrete event simulation. It's not focusing on the impacts of resources, things like waiting times and queue length and throughput and various measures of service efficiency. It's not necessarily focused on services. That being said, microsimulation modeling is, from the standpoint of traditional agent-based modeling, it tends to focus on like empirically informed hypotheses how people go between various measurable states. And so it's kind of stands out from a lot of dynamic modeling traditions in the sense that it, maybe because of the origin of many of these models, it tends to privilege like observable states, because it tends to be instantiated from things like census data and large scale administrative data here in Canada. So the POEM model, for example, or OncoSAM, mod in the ModGen frameworks in which they're based, well, they have a somewhat broader frame. They're really focused more on observables. The second thing is so they don't have a lot of latent states often. But more than that, and arguably as important for the distinction from traditional ABMs have tended to emphasize like emergent behavior coming from agent-agent interaction or agent-environment interaction. How do agents' behaviors, like interact with each other in the environment, ripple up to emergent behavior at the mesoscale, kind of the medium scale, and the macro scale, the highest scale. We saw that this morning, right? We looked at that like infection curve, for example. That would be at the macro scale. If there were some intermediate scale, like we had agents in neighborhoods, maybe we'd look at dynamics across neighborhoods or across schools, right? Number of infected people across schools or across workplaces. That might be kind of a mesoscale, medium scale. So that's been the traditional emphasis of a lot of agent-based modeling. Is like, how do the agent-agent interactions or agent-environment interactions like ripple up to emergent effects? And for a lot of microsim, that's absent. You're simulating each agent in isolation, and therefore they simulate many agents at the same time because they don't have to interact, which from an agent-based modeling standpoint is kind of like you've kind of discarded many of the most important things. So microsim and agent-based modeling, well, they're kind of close cousins. They have rather different philosophical bents. Microsim is much more kind of tied to empirical data and much less. It doesn't have the kind of broad embrace of latent state and so on that ABM does. And it also doesn't capture agent-agent interaction. I tend to group them both in individual-based modeling traditions, but I talk about agent-based modeling more commonly for what's the focus of this bootcamp, where there is a lot of emphasis on agent-agent interactions or agent-environment interactions or what have you. Now, I've gone a step further, though, in some of my writing that writing I referred to, because truth is, some agent-based modeling takes place without reifying, without recognizing as like a thing in the model an agent, like representing what we might call in software engineering an object as an agent, like a thing you can point to, like there's the agent right there. That's it, without representing that as its own like construct in the model. And traditionally, that is what agent-based modeling does. And people have argued, oh, that's why it's such a good match to, for example, what are called object-oriented programming languages. And there's a whole subliterature related to that. But the truth is, a lot of agent-based modeling can get done in a way that just represents like, I'm going to use the word vector. I hope it doesn't scare people, but like vectors of attributes across the entire population, where each index one is agent one, or is person one. Index two is person two. And the vector might represent their age, and then another vector might represent their infection status, SI or R. So for the first element of that vector would be for person one, or they susceptible infector to recover. And, there might be another vector for their employment status and another vector for their smoking status or something. And the kind of evolves them without having like an agent that's there. There's no there. There's no like agent you point to. There's agent one. No. It's kind of distributed among these arrays. Like it's index one. It's like the first person one is the first one in the protection state array, the first one in the age array, the first one in the in this and these vectors. Forgive me for lapsing into arrays. First one in the vector of employment status, first one in the vector of location, blah blah blah. So there's like no agent. It's like it's not agent-based modeling, it's individual-based modeling. We don't represent the agent like as a reified thing, as a thing that is materialized, like that we can point to and say that's the agent right there. So I've been known to call that individual-based modeling and say, look, it's an individual-based model. It ain't an agent-based model. But I have too little time in this world to fight these battles. And honestly, this is not a hill on which I want to die. I mean, it's not I don't see it as a hugely consequential thing. I'm just throwing out some things which have struck me as kind of important distinctions, which are kind of glommed in. If people willy-nilly use ABM or IBM, they got to be a little bit careful because you may be grouping things that are not quite alike without realizing it. And you may be glossing over certain distinctions that are useful to bear in mind or useful for kind of understanding diversity of approaches to these things. So I'm sorry for the long answer, but that's individual-based modeling versus agent-based modeling. And I'm going to